Hello everyone and welcome back to my YouTube channel. Today we are discussing the solution of internal test 1. So we are starting with question number 1, which is how is unstructured data analyzed in the context of data science? Provide an example of a data mining activity used to analyze unstructured text data. How can text mining techniques can be employed to automate the classification of written complaints? Answer of that question. Unstructured data refers to information that does not have a predefined data model or organization. Examples include text files, images, audio files, and videos. In data science, analyzing unstructured data often involves converting it into a structured form suitable for analysis. This process typically includes techniques such as natural language processing, text mining, and machine learning. Example of a text data mining activity. Consider the analysis of a customer complaint in text format submitted to a service center. The goal is to classify these complaints into categories. Example, billing issues, service disruption, or theft. The steps for analyzing unstructured text data include first, preprocessing the text, which is tokenization, which means breaking the text into individual words or phrases. Stop word removal, eliminating common but irrelevant words like and, the, and is. Stemming and lemmanization, reducing words to their root forms. Second, text representation. Bag of words, representing text as a collection of word frequencies. TF-IDF, term frequencies, inverse document frequency, weighting words based on their frequency and uniqueness. Word embeddings, representing words as vectors using models like word2vec or GLOVE. Classification using machine learning. Algorithms like support vector machines, decision trees, or neutral networks can be classified, used to classify the text data into predefined categories. Text mining techniques or automation. To automate classification, a text mining pipeline is developed. Data collection, collecting complaints from various sources such as emails or web forms. Data preparation, use pre-processing techniques to clean and organize data. Feature extraction, converting text into numerical data using TF-IDF or embeddings. Model training, train a supervised learning model using labeled complaints. Deployment, which means deploy the model to classify incoming complaints in real time. For instance, if a complaint mentions theft and mobile phone, the system can classify it under the category of theft using predefined words, keywords, or patterns. Question number 2, which is discuss the specific methods or technologies that facilitate this process. Given the following complaint, describe the approach, algorithm, or processes for identifying applicable IPC, Indian Penal Code, and BNS, Broad National Categories section. Bharati Nyaya Sanhita sections. Complaint. Theft of my mobile phone by an unknown person at MG Road on 2023-02-20. The phone was stolen when I was shopping at a store. The thief was wearing a black jacket and had a scar on his face. Answer. To process the complaint and identify applicable IPC and BNS section, the following steps and methods are used. First, natural language processing, NLP pipeline. Named entity recognition, NER, identify named entities like MG Road, locations 2023-02-20 date, mobile phone object. Keyword extraction, extract words like theft, store, and unknown person from context. Dependency parsing, understand relationship in the text to identify the subject theft and its attributes. Algorithms for classification. A rule-based approach can map keywords, example theft stolen to IPC section, example IPC section 378 for theft. Alternatively, supervised learning models trained on labeled complaint data can predict the most likely IPC and BNS categories. Third, process workflow. text pre-processing, which means clean and tokenize the text. Feature engineering, use TF-IDF or embeddings to extract features. Model application, apply a classification model, example logistic regression, random forest or BERT to determine IPC and BNS codes. Output mapping, map the prediction to relevant IPC section, example section 378 for theft and BNS category, example property crimes. Technologies, NLP libraries use library like SPASC and LTK, our transformers for textual analysis. Machine learning frameworks use tools like SCIKIT Learn, TensorFlow, or PyTorch for building classification models. Database integration, connect to a legal database to validate the and retrieve details about IPC section. Example output for the given complaint. IPC code section 378 theft. PNS category. Property related offenses. Question number 3. What are scalable data structure and algorithms for addressing and the tasks described in question number 2? Explain how these structures and algorithms can be applied to effectively classify the complaints into appropriate IPC or BNS section. Answer of that question. Scalable data structure and algorithms ensure efficient handling of large volume of unstructured complaint data. Scalable data structure. First, tree, which is prefix tree, used to store keywords, example threat, robbery, for quick lookups during text processing. Helps in matching phrases in the complaint with predefined legal terms. Second, hash tables. Store mappings between keywords and IPC BNS codes for efficient retrieval. Example, theft 378, robbery 392. Third, inverted index, a key structure for searching text. Maps words to document complaints where they appear, enabling fast keyword searches. Scalable algorithms. First, TF-IDF vectorization plus linear models. Quickly convert text to numerical form for classification. Lightweight models like logistic regression scale well with large datasets. Second, hierarchical clustering. Group similar complaints for batch classification. Reduce computational load by processing clusters instead of individual complaints. Third, distributed system. Use frameworks like Apache Spark or Hadoop for parallel processing of complaint data. Ensure scalability for millions of complaints. Application to the task. Complaints are indexed using an inverted index for keyword matching. Pre-processed data is vectorized using TF, IDF and fed into a trained classifier. Results are stored in hash tables for fast retrieval of IPC BNS codes. Now we are going to the last question, which is question number 4. What methods are appropriate for assessing the performance of algorithm used in text mining? Detail the matrices that evaluate the effectiveness and accuracy of text mining techniques. The answer of solution of this question is the performance of a text mining algorithm is assessed using various evaluation metrics and methods. First, matrices for classification models. Accuracy means measures the proportion of correctly classified complaints. Precision, fraction of relevant results among retrieved results. Recall, fraction of relevant results retrieved, which is the sensitivity of that retrieved data. F1 score, harmonic mean of precision and recall balancing both matrices. Second, matrices for NLP models. BLEU, which is bilingual evaluation and understudy, evaluates the quality of text generation, if applicable. Perplexity measures the uncertainty in predicting the next word in a sequence. Word error rate, which is WER, means assesses transcription accuracy. Third, cross-validation. Split the dataset into training and testing sets to validate the model's performance. Fourth, real-world testing. which means to deploy their model on live data and measure its accuracy in predicting IPC PNS scores. By regularly monitoring these matrices, algorithm can be refined to improve their effectiveness and accuracy. This is the conclusion of this question paper solution. We have discussed all the questions and have given the detailed solution to the every possible question. Thank you for watching this video, and we will meet in the next video discussing the other question papers too. Thank you for giving your time.